I think it's in 126. All right, so by and large, really nice work on the midterm. Lots of opportunities to get kind of nickeled and dimed, which brought some people's grades down. But as far as doing the coding and writing the algorithms and things like that, I was very happily impressed with where everybody seemed to be. So I think you're in good shape as far as programming goes and as far as C and Bash so far. So keep doing what you've been doing. If you feel like you were shaky on these problems, there's a few possibilities. One, right, it was only 50 minutes and there were 5 programs to write. And it could be a time management issue. It could be that test conditions where you're writing on paper with the clock ticking are not ideal, right? Most people, including myself, tend to work better in front of a terminal where I can actually write code and compile it and so on. But the solutions to those are generally more practice, right? Just spend more time doing this and try to write your code maybe more under test conditions, right? Instead of immediately going to the compiler to look for syntax errors, see if you can get better at sort of figuring out what you're trying to do up front. But let me run through these and I'll make some specific comments on things I saw. So first page was short answer, Linux type questions. So why are makefiles used? They do 2 things from this list. They let you only compile parts of a project that need to be recompiled. So you change one line of code in one file and that's the only thing that needs to be recompiled. If you just say gcc star.c, everything gets recompiled. With a makefile, it would look and it would say this is the only file that changed. It'll recompile that, and if other things need to change because of that, it will pick those up, but it's very specific in what it rebuilds. And it makes the project simpler to rebuild because all you got to do is say make, and it compiles everything, links everything together, it puts in all the libraries, the include files, and so on and so forth. So it's really both of those. The echo statement, x equals 12 plus 3, echoes 12 plus 3, x equals $12 plus 3 echoes the value of 12 plus 3, which is 25. I had a few 26s in there for some reason. I didn't take off for that. X equals single quote stuff will just echo that stuff. Right? Single quote suppress the evaluation of the $. GDB set a break at my function. You can just say break space my func. Right? Or if you know the line number of my func, you can say break space and the line number. But that sets up a breakpoint and says when you get here, stop executing, come back. Execute your code until it reaches the breakpoint would be continue, or if you just started GDB, you could say run or start. Step or next will not run until the breakpoint. It'll only run for one statement. Examine the value of variable myvar. You want to say print myvar or maybe display myvar. X myvar would be trying to examine a memory location corresponding to myvar, and whatever value myvar has, that's the location you would look at. So it's not looking at the value of myvar, it's kind of dereferencing a pointer. And then continuing execution of your code after a break. I'd really like you to say continue, but if you said next or step, I gave credit, because technically you're continuing execution at that point. But again, next or step really only executes one thing and then comes back. Continue says just keep running until you hit a breakpoint or the program exits or you get an error. So the series of statements here, x is pwd, that sets x equal to pwd, 3 characters. X equals back quote $x sets x equal to back quote pwd. That runs the pwd command, captures its output, and sets x equal to that. So now when you echo $x, it shows you what your current directory is. So if you had something along those lines, you got credit for it. Single Linux command that would change the name of a bash script named myscript to main, that's just mv, that's the rename command, move myscript into main. I think everybody got 6. Why would you want bin bash at the top of your script? It's really if you want to force your script to be run with bash. And almost everybody had this bin bash in the top of their programs that were written in bash, so that was good. And then single Linux command to create a tar file, so tar cvf, name of the archive, and then name of the things you want to put in the archive. If you say tar cvf and you list your files and then archive, you destroy that first file, right? That becomes the archive. And if that's main.c, now your archive is called main.c. and your actual main.c is gone. So unless you have a backup, you lost your main program. So CVF, first thing has to be the archive name. There's no dash on CVF. I didn't take off for that because most Unix commands have dashes on their switches. For some reason, tar doesn't. But tar CVF. All right, so let's talk about the programs. So a function named count, and it takes two arguments, a character named ch and a string. And you could call these whatever you wanted. Okay, this is the prototype up here, right? It's a prototype, so it's got a semicolon at the end. When you're actually defining the function, you don't put a semicolon there. You put an opening curly bracket. And you want to count the number of times that ch appears in the string. So you need some kind of running counter. You need to initialize it to 0. Okay, you've gotten that from ODPs, if nothing else. And then you want to iterate over the characters of string. Two main ways to do that. One, you can do a while loop until the character is the null pointer, or two, you can use a for loop. Okay, and I said you can use the string length function, so that was a bit of a hint. So I'm going to use that because for loops are fun. So for integer I equals 0, I less than string length of string I plus plus. And your goal is to see if character I of your string matches this character. So if string I equals ch, increment the number of times we've seen it, and then return num. So anything equivalent to that will get you full credit. Issues, not initializing the counter. Comparing your null terminator to 0 instead of quote \0. 0 is an integer, it's 4 bytes. \0 is a single character. Various issues with while loops. If you have a while loop, you want to increment I at the bottom of the loop. If you increment I at the top of the loop, you don't check the first character, right? That can throw you off. A number of people, I think it was mainly in the B section, tried to compare this to single quote ch, right? Which is a compile error because single quotes need to enclose a single character. And even if it was acceptable, you'd be checking to see if this was equal to this particular character, right? Ch is a variable, it's an argument. It accepts a character ch and a string str, and you're supposed to look for that character. Some people did string length -1, which skips the last character, right? So make yourself an edge case, HELLO. This last character is index 4, the null terminator is index 5, and the string length is equal to 5. So if you kind of keep this in your head or on your cheat sheet or something, right, or whatever test case you like, it tells you the last character you want to check is string length -1. So if I go up through where I is less than string length, that gets me to exactly string length -1. If I actually go up to where it's equal to string length, then the last thing I'm checking is the null terminator. May or may not be a problem. If I go to string length -1, I'd only be going through character 3, and I'd be missing that last character. So that's just edge cases. Some people did things like this, or things like this, right? Which sometimes we do stuff like that, but what is this doing? This is incrementing character I of our input string, right? You really don't want to change your arguments to your function unless they're purely local or you're asked to change the arguments. And incrementing ch, that's a local variable, so it doesn't do any harm, but it changes the character that you're looking for each time you go through this loop, and that's just different from what we want to do. and make sure that when you index an array, you're not using parentheses, you're using square brackets. Make sure you're using double equal for comparison, all the usual stuff. All right, smallest function, not a whole lot of issues with this. So except two integers, return the smaller of the two. If they're equal, just return either one. It doesn't matter which one. So I mean, if you want to be really slick, right, there's a one-line version of it using the ternary operator. So if x is less than y, we return x, otherwise we return y. But if you want to be more sort of traditional about it, if x is less than y, return x, return y. There's a two-line version. You could put an else here if you want, it doesn't hurt, but you don't need it because if this if statement is true, your function returns. The only way you're going to even get to this line is if the if statement fails, so the else is sort of redundant, but you could put it in if it's sort of natural. But that's really all you need, right? If x is smaller, return x, otherwise return y.
What's the return x less than y question mark?
So that's a ternary operator. So it says evaluate this condition. If this condition is true, this expression is equal to this thing before the colon x. If this condition is false, then this expression is equal to the thing after the colon, which is y. So it's a shortcut. It doesn't do anything you can't do with just an if-then statement, or an if-then-else. But it turns out to be very handy sometimes. So some people got this backwards. They ended up returning the larger of two arguments. Some people tried to use an scanf in here, which isn't happening as much as it used to in other classes, so that's good. But scanf is only used when you want to take a string and convert it into an integer, right? And there's no strings involved here. If you're passed an integer, you can just use x and you've got the integer value, right? If this was a car star and it was like, quote 24 and you wanted to convert it to an integer, then you have to use scanf, okay? Similarly, there's no fgets, there's no getCar, there's no printf, okay? Unless it says read from standard in, read a runtime argument, a runtime input, or print something out, right? You don't need to use that. Make sure you don't leave any dangling cases. So in some cases, I saw something like this. If x is less than y, return x. If y is less than x, return y. And that was the end of the function. Well, if x is equal to y, neither of those if conditions fires, and you fall off the end of your block. A good compiler will say, no return condition at the end, but you'll return whatever happens to be sitting on your stack, and it's unpredictable. So just think about edge cases. All right, so the C programming looked really good to me. The bash programming was a little more interesting. So this program, main program that expects a command line argument, if no argument's given or more than one argument is given, print no arg. If a single argument's given but it's not an integer, print not int. Otherwise, print either 1, -1, or 0, depending on whether the argument's -0 or positive. And then exit after printing a single line of output is described above. So since you want command line arguments, you got to do the argc, argv thing. All right, so there's how we get the arguments. So argc is the number of things on the command line, okay, including the program name itself. So if you run this with exactly one argument, if you say something like main 27, argc equals 2. And the program name is argv0, and the first argument is argv1. Okay, if that's not clear to you, that should be on your pages of notes, right? Because argc, argv always is confusing, right? And it's different from bash, which makes it even more confusing. So argc is the number of arguments, including the program name. So in this case, we want one argument. We need argc to be equal to 2. So here's an idea. If argc is not equal to 2, go ahead and print out your message, which is no arg. And return. And when I write this, I like putting a return right here. I could just say print out no arg, close curly bracket, else if something else, do this, close curly bracket, else blah 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 blah, right? But if I put a return here, I close out this whole block, right? And I know I'm never going to get here in my program unless this if condition failed, right? And what this does is it lets me avoid nesting deeper and deeper and deeper as I go down. If I have 20 conditions I'm checking for, and I just keep using else's, right? I got to keep in my head 20 levels of nesting if then else's, right? Here, if argc is not 2, print my error message, return. I'm done, right? So if I get here, I know argc was equal to 2, right? Which means I have exactly one command line argument. So is argv1 an integer? All right, so up here, my comment might be, do we have exactly one arg? Okay, so here's argv bracket 1 an integer. How do we do that? scanf. A lot of people, sometimes people I don't see in class very often, started going crazy looking at is digit and is there a minus sign in position 0 and setting a flag if there's a minus sign and looking for spaces and all kinds of stuff. scanf does this for you, okay? It's fairly tricky to parse an integer by hand. Some of these people did a really good job of parsing though, right, which I was impressed with. But it's a lot of work, right, and it takes a lot of time. You only got 50 minutes. scanf is your friend, right? So integer result equals scanf argv1 %d address num, and num's got to be an integer. All right, so we take that argument and we try to convert it as an integer and store it in num. And again, if the result is not equal to 1, it wasn't an integer. For some reason, it couldn't convert it. So we'll just print an error message and return. Otherwise, we did have a single argument. It was a valid integer, and its value is in this integer called num now. So now it's just a set of if statements. So if num is less than 0, print a 1. Else if num equals 0, print a 0 or a -1. Else, well, I could say if num is bigger than 0, but I also know if it's not less than or equal to 0, it's got to be greater than 0. This is my only other case. So I'm just going to say else print 0 and then return. So something like that. Again, there's always different ways you can write this, but that's the effect. The important thing is you got to check argc before you use argv bracket 1, right? If you do this first, you risk a seg fault. if you don't do a return and you don't do an else and you simply fall through from here to here, argc was not 2, you printed out an error message, but now you're trying to use argv bracket 1, you don't know if argv bracket 1 is available. So possible seg fault there. Same thing if this returns something other than 1, so it didn't successfully parse an integer, but you don't exit here, and now you start using the value of num, one of these conditions is going to fire, and you're going to print 1 minus 1 or 0, even though you didn't have an integer, right? So program flow considerations. So here's some of the things that I saw go wrong in here, and we mentioned some of those already. When you scan, you got to use %d, maybe %i. Don't use %lf. That's for a floating point. Okay, it will complain and say, well, it'll be a floating point, but it won't store it successfully in this integer. It'll store it as if it was a floating point or a double. Anything else I need to say in here? I think that's the bulk of it. Again, scanf, make sure you're comparing the result to 1. Don't just say if scanf, because scanf can return something non-zero but still have failed. Right? If the argument is an empty string, it'll return -1 when you try to scanf, and it won't load an integer into here. So if you say main double quote with nothing in between, scanf won't return a 0, it'll return non-zero, but it's still an error. So you got to compare the result to 1 if you're trying to parse one thing. All right, questions on that? All right, let's see. Expect 2 arguments, print all integers between first and second, including first and second, 1 per line. Both arguments are given, both integers. First is less than or equal to the second. Must use a while loop. So put your shebang in the top. So your first argument is $1. Your second argument is $2. Okay, those are always available for you. You don't have to check $number because I said you can assume you got 2 arguments. Okay, and you don't have to check to see if they are equal to themselves as a string to see if they're an integer and so on. You can assume the arguments are all what they should be. So we want a while loop. You can't increment $1. You can't say 1 equals $1 plus 1, right? And you can't say $1 equals $1 plus 1 because $1 gets replaced by its value. So you need a variable that you can actually modify. So we could do something like x equals $1 while $x less than or equal to $2 do echo $x equals $x plus 1. Done. There's your loop. Right, so it compares x to less than or equal to, so when it gets up to the value of your second argument, it will still continue to loop. It will print it out. When it adds 1 to that so that your x is now greater than your second argument, the while loop will fail and it'll kick out of the loop. So, so issues there, not doing the while loop properly, using parentheses, using single brackets, using single parentheses, using the less than sign in here.
You had mentioned something in class about not using like dash eq, but using equal instead.
Use equal or exclamation equal for strings. Use the dash things for numbers. So this would actually work with an equal, right? Because a string will be equal to a string, but ideally it should be a numeric comparison, but if you used equal equal, I should have given you credit for it.
No, I used a less than
Oh, okay, so yeah, less than equal doesn't exist.
yeah, because I was confused after.
Okay.
That, but that's fine.
Yeah, comparing numbers, always use one of these. Right, so that's for numbers. Comparing strings, use one of these. Equal, equal, or not equal. So $1, $2, those are your first two arguments, okay? The indexing is a little weird sometimes. And sort of minor algorithmic stuff. If you do this increment before the echo, you miss the first number, right? And you actually go one number too far, right? So your number is in range, echo it, and then increment. And before you echo that new number, make sure it's in range by coming up to the top of the while loop. That's just kind of a practice thing. If you say x equals, quote, $1, that sets x equal to the string $, followed by a 1, right? If you do double quotes, that'll work fine. If you have no quotes, that'll work fine, but single quotes will suppress the $, from being treated like a $. Various small algorithmic things, either an extra echo at the end or an extra echo in the beginning where you were double printing some numbers. Think through what you wrote and see if that makes sense. That was probably about it. In some cases, I saw some really unusual code that was different from anything we've ever talked about, but I tried it and it actually worked. But for example, one person did this. Right, parentheses, parentheses, x plus plus, no $, anywhere in sight. But it actually works, it actually increments x. But
That's weird.
yeah, I thought it was weird. So, I mean, if that's near and dear to you and you like doing that, fine. But if you thought that would work based on what we had discussed, then you want to go back and look at what we discussed, because the way we would have done this would have been something like that. So, but if it worked, I gave you credit for it. All right, and then the last one, bash script, reading input from the user, adding it to a running sum, printing out the sum, and exiting when your sum is bigger than or equal to 20. So, the usual at the top. And then sum is your running sum, so you can set that equal to 20. So you want to exit when your sum is bigger than or equal to 20, so you want to loop while your sum is less than 20. Okay, and the first thing you want to do is read a number, and then you want to add it to your sum, print that out, and then continue checking. So, read number, sum equals number plus sum. Echo sum equals sum. Go back up to the top, and then just echo done. Alright, so read a number, add it to your sum, print out the running sum, and keep doing this until your sum is bigger than or equal to 20, and then just echo the word done.
I thought let them equal to me, so we're gonna stop at 20. I thought that.
So if you do less than or equal and your sum's equal to 20, it will have printed out that sum, but it will continue asking for a new number, right?
So this should be okay for something 17, 18, 15.
17, 18, 19, it should keep going, but if your sum's 20, that's it, it should stop.
I thought it's gonna be stop at 20.
Oh, okay. Yeah, no, do this until the sum's bigger than or equal to 20.
Oh.
So I gave a lot of points for this, but kind of issues I saw. So again, the usual thing with while statements, parentheses, double parentheses, single brackets, all of that stuff. Echoing on the wrong side of the summation, having the wrong condition here, having less than or equal to, that was fairly common. Some people did greater than or equal to, which would only loop while your sum was above some number, and since you start off with your sum at 0, your loop's going to exit immediately, because 0 is not bigger than or equal to 20, so your loop wouldn't actually do anything. Some people did a read at the top and a read at the bottom, just all kinds of things, and this was the last question, so I think time pressure was kicking in, which was why I graded it a little more gently. Saw a few cases where this read was a read -n1 num, right? Don't do that. The -n1 says wait until the person hits one key and then come back, which means you can only type a single digit for your number, right? That's not what we want here, right? We want to be able to enter something like 15, for example, and if you do this, it would come back right after the 1 and it would say your number was 1. So that's useful and it's pretty cool, but don't use it unless that's really what you want to have happen. I saw one of these. While space single bracket true. That actually works, but not for the reason that you probably think it does, right? I could have said while bracket false and it would also be an infinite loop, right? It's picking up the fact that this is not an empty string. And the single bracket happens to be working in this case, but unless you really, really know what you're doing, don't use that, okay? Do something like while bracket bracket 1 equals 1, you know, equals 1 or -eq1, or something that's true. But you don't need an infinite loop if you can loop on some condition, right? But you can do an infinite loop and then check your condition inside the loop and do a break or a return or an exit, not a return. But right, that's sort of the more standard way to do it. So some other things that aren't wrong, but I wanted to point out. I've seen things like this, both in C and in Bash. Right, temp equals x plus 1, x equals temp. So what's the effect of these two instructions? Well, pretend it's C.
It's just incrementing x.
It's incrementing x, right? So you can do this like x equals x plus 1. But I find, particularly in this course, there's a segment of students who aren't comfortable with this, right? Because we've got x on both sides, but this is absolutely perfectly legal. This is totally legit. Now this works fine, right? But if you're doing this because you're not sure that this is kosher, right? Be assured this is totally legal, okay? And it's a more efficient way to do this. It takes one instruction instead of two, and it avoids a temporary variable, and so on and so forth. So don't be afraid to do this. All right, this is good.
Does the compiler treat both of them the same?
A good compiler might. A good compiler might notice that temp is never used anywhere, and it might actually replace this with just an increment x. But a cheap compiler, probably not. Another thing, right? So I saw lots of code where it said something like I equals 0, read J, and then I equals J plus I, echo I equals $sum equals $I, right? That's fine as long as you don't mix up I and J, right? In some cases those got mixed up. And yeah, you're writing this by hand, so you don't want to say, you know, the running sum that I call sum, right? But calling it something other than just I and J or X and Y or A and B might help you keep things straight, right? I mean, sum and num is 3 characters instead of 1, but it's not that much extra writing, right? But I also see this in people's code that they submit in ODPs and stuff, right? Don't be afraid to use meaningful variable names, right? If you're just iterating in a for loop, right, and you say integer I, that's not a big deal. If you're only using I inside that loop and you're just using it to index an array, that's pretty standard. But don't be afraid to use words like num and sum and count and things like that. It may help you avoid issues. I think that's pretty much it. So any remaining questions? Number 4, multiple choice.
Oh,
This one?
yeah.
So
I didn't see.
So x equals PWD. Well, let's just. So x equals PWD. So that's what x is equal to. It's just PWD. Now, if you say x equals back quote $x, right? $x is PWD, so x is equal to back quote PWD. If you look at the value of x, it's your current directory, right? It's exactly what would happen if you just said PWD. So it captures the output of that command. All right, let me show you your final lab. So I posted lab 4 last night. I don't want you to end up spending a lot of time on labs. So I'm only doing 4 labs instead of 5, but I don't want to take off points. So lab 4 is worth 40 points, and you've got 3 weeks to do it. So, what? Yeah, but it's like doing 2 labs, but it's 1 lab, so you can get it done in less time. So let's see if I can do this. I bet I can't because the pressure's on. All right, so let me show you your lab. So lab 4, you're going to write a Morse code system, right? So I can say hello. And my LED will blink out hello in Morse code. So this is like, you know, the famous desert island scenario. This could actually help you, right? So the standard test is SOS. Should be 3 short flashes, 3 long flashes, 3 short flashes. So this is one of the 2 things you get to sign off on. So there's 3 short flashes. There's 3 longer flashes. That's the O, and then 3 short flashes is the S. So that's a good test case.
So this include the terminator, new terminator.
So there's lots of details that we'll go over tomorrow, and you can read the lab write-up, and it covers all of it. But you're only going to do letters A through Z. Everything else you're going to ignore. So, right, so spaces and all that stuff get ignored. But we'll go through the write-up in detail tomorrow. But feel free to look at it and start in on it as you like.